So this is 6.4C, college algebra, still dealing with nonlinear systems of equations and inequalities. So we're going to do the modeling and problem solving here. Top of page 562, we've got for a student recreation building at Southport Community College. We don't care about any of that. An architect wants to lay out a rectangular piece of land. All right, so we've got this rectangular piece of land that we're going to build a building on. And the perimeter is 204, and the area is 2565. All right, so let's call this the length and this the width. All right, so I know that 2L plus 2W equals the perimeter. I also know that length times width equals the area. So pretty easy to find my two problems that I'm doing. And let's see what we've got here. Let's use substitution. So let's say that L equals 2565 over W. So now whenever I see an L, I can put that in right there. So I'm going to get 2 times 2565 over W plus 2W equals 204. Okay, I can do that. And if I multiply both sides by W, and I'm going to end up with 2W squared plus, what is 2 times 2,565? So that gives me 5,130 equals 204W, because remember, I multiplied the entire thing by W to get rid of that fraction. Okay, so 2W squared minus 204, setting it equal to 0. See, this is why you learned all that other math, is so you could do this. Factor out a 2. Okay, and you can use Pythagorean, or you can see if possibly you could divide it into 2 here. So we've got that 57 and 2 give me 5745. When I add those together, I get 102 multiplied. I get the 2,565, and they're both subtracted, so that I can get a positive here and a negative here, because I'm going to add those together. So that means my W equals 57, and it also equals 45. Okay, so what's this going to look like? Well, we're going to plug both of these numbers in, and when we plug 57 in, we're going to get a width of 57 and a length of 45. If we plugged in the width of 45, we're going to get a length of 57. Okay, so what does that mean? It means that if our width is 57, our length is 45, or if our width is 45, our length is 57. Okay, so for the most part, it's just semantics here. Normally when you find dimensions of something, okay, so the dimensions are going to be, the length is usually referred to as being the longer of the two between length and width. So here is going to be our answer, only because our length is usually the longest and our width is the shortest. So that's why we're using that. Both the answers are really right. It doesn't really matter if you say it's 57 long or 47 long. The fact still remains, when you plug these two numbers in, you're going to get the same answer. So anyway, that is example 5. So let's do 2 more examples, 6 and 7, on nonlinear systems of inequalities. So dealing with nonlinear systems of inequalities, the only thing that's going to be different here is we're going to be shading some of the graph. We're going to be doing everything the exact same. We're just going to be shading some of the graph. All right, so let's look at example number 6. So we have x squared plus y squared is less than or equal to 25. Okay, so we know that's a circle. We've got a linear equation or inequality. Okay, so we're going to, first of all, it just asks us to graph. We're going to graph this circle. I know that it's on the origin. I also know that the radius is 5. So makes it real easy. 1, 2, 3, 4, 5. It won't be a very pretty circle, I can promise that. Okay, let's pretend that it crosses at 5 on all those, even though it doesn't look like it. Then we graph this linear equation. First of all, let's look at what we've got here. When we have something like this, and we're going to graph it, and then we're going to shade it because of the inequality, we plug a number in either inside the circle or outside the circle to see which one of these makes this a true statement. So let's say that I plug the point 66 in for this equation into this top equation because I want to find out if 66 works. If it does, then I shade everything outside the circle. Okay? If 66 doesn't work, then I shade everything inside. Okay, so let's try this. 6 squared plus 6 squared is less than or equal to 25. 36 plus 36, is that less than? No, it is not. So that means we shade inside the circle. So, okay, so for this equation is less than 25, that means we're going to shade inside. And it's kind of nice. You can look at this and go, less than 25 or less than the square root of 25 or less than 5. Yeah, it's going to be the inside. All right, now let's look at this one. This is a greater than sign, so it's going to be a linear equation that's a dotted line. So we draw our linear equation that's a dotted line, just like this. And we need to find out whether we shade above the line or below the line. And again, we plug in a number. It doesn't matter what number. Let's put in 0, 2. So if we put in 0, 2, that's going to be a point. Whoops, God, what am I thinking? 0, 2, right here. So if 0, 2 works, if it makes it a true statement, we're going to shade above the line. If 0, 2 does not work, we're going to shade below the line. So 0, 2. So we're going to take 3x minus 4y, 0 for x, 2 there. 0 minus 8 is greater than 0. So is negative 8 greater than 0? No, it's not. So 0, 2 does not work, which means no number above the line works, which means we're going to be shading everything below the line. And what we're interested in as far as a solution set, we're interested in the portion where they're both shaded. This little half circle right here. That's what we're interested in as far as our answer is concerned. Okay? So if we're interested in finding the points of intersection right here and right here, we can take this here, use the system of equations, and solve this using substitution, just like we did in the other problems, and we'll find out what 2 points are the solution set. So that's the second part of this equation, is to find out what these 2 points are. Okay, so you go ahead and draw this and shade it and get the solution set there, or as far as what the graph looks like, and then you do what we did in the earlier parts of this video, and use the system of equations, elimination or substitution, to find x and y, so you can find these 2 points right here. And I'm not going to do that. We just did a couple of those, so it shouldn't be too terrible to do that. Alright, so one more to go and we'll be done. And I think I'm going to go ahead and do it on a new video just to make sure I have enough time. So anyway,